Hello everyone, I am Dr. Siraj Lakfasi. I welcome you in my YouTube channel. Today in this video, I am going to talk about the structure and preparation and properties of 7-member ring. One compound is thiopine and other is azepine, or sometimes we call it azepine also. The structure related to 1H azepine that bear an oxygen atom is known as oxepine, and if it is nitrogen or sulfur, then we call it thiopine, or sulfur, then it is called thiopine. So these are class of oxygen or sulfur containing 7-member heterocycle molecules. You can see here the oxepine and thiopine. If oxygen is there, then oxepine. If sulfur is there, then thiopine. If nitrogen is there, then azepine. This heterocycle has 8 pi electrons and obey 4n pi electron rule, hence anti-aromatic in nature. Now, oxepine and thiopine exist in non-planar conformation and are non-aromatic compound. You can see here best conformations when it is oxygen and sulfur, that is the boat form, and the shear form. Oxepine is much more stable than thiopine and has been synthesized, isolated and characterized at room temperature, while thiopine has not been डिटेक्टेड. सो ये जो दो फॉर्म देख रहे हैं, एक फॉर्म आपका बोट फॉर्म है, दूसरा चेयर फॉर्म है, और ये दोनों जो फॉर्म होते हैं इट विल एग्जिस्ट इन इक्विलिब्रियम, राइट. नाउ oxepine, due to inability of most monocyclic oxepine does not have any common application, but they do play a remarkable role in intermediate in biosynthesis and metabolism of natural product and xenobiotics. Oxepine at room temperature exists in rigid equilibrium with its equivalent tautomer benzene oxide. You can see the oxepine is easily converted into benzene oxide. It means 6-member ring and 3-member ring. Another things you can see, the monosubstitute oxepine support the existence of the two enantiomers in equilibrium with the oxepine. Now you can see. So the oxepine benzene oxide ratio depends on temperature, solvent and substitution. Oxepine form favor a less polar solvent, while at low temperature the benzene oxide is preferred form. So less polar solvent, oxepine favored, and less polar solvent means benzene oxide is less favored. So in low temperature you can see the situation. Now substitution at carbon 3 favor benzene oxide tautomers, while substitution in carbon 2 favor oxepine form. You can see carbon 3 substitution, and in this case carbon 2 and carbon 4 substitution favor the formation. Now synthesis from cyclic compounds, the 3, 4 and 6-member carbocycles have been employed as a starting material for the construction of the oxepine ring system. Most synthetically useful method involve cyclopropane and cyclohexene as starting materials. The most efficient method for synthesis of dihydro and tetrahydroxepine involve ring expansion of alkynyl cyclopropyl carbinol. You can see these 3-member carbocycle. Now after using this reagent it become like this, that is unstable, and after 3,3 reagent, you know the pericyclic reaction, after 3,3 reagent you will get this oxepine. Now from 4-member carbocycle, this is the 4-member heterocycle, that is the bicyclo 2,2,0 hexa 2,5 diene undergo epoxidation reaction followed rearrangement of the resulting tricycle like this lead to the formation of the oxypene. Now 6-member carbocycle. You can see the 6-member carbocycle formation of oxide, and then you can see the bromination and then dehydrogenation. You will get this product. Friend, the electronic nitrate of nature of the substituents is the cyclooxydiene ring determine of the two possible substituted oxypene in the form and depend on which two double bonds are initially involved in the epoxidation. If substitution is electronic donating, then it lead to the formation of two substitution. You can see this 6-member ring converted to epoxide, and then bromination, then base, then it is in equilibrium, and this form is more stable, 3 substituted oxypene. If the substituent is electron withdrawing, then it lead to the formation of the 4 substitution epoxine like this. Now friend, photochemical and thermal reaction. You can see this compound is undergo in the light, presence of light, thermal rearrangement, and then after heating you will get this product oxypene. Diels-Elder reactions, this is very important examples of the furan. Furan undergo Diels-Elder reaction with the triple bonds and forming this. Now you can see the numbering scheme before the epoxide formation and after epoxide formation. Now cycloaddition reaction, you can see these compounds undergo cycloaddition reaction and forming this product. Reaction with the with electrophiles, a lot of product form. Reaction with nucleophiles, you can see the formations of epoxide and then ring open of the 3-member ring and forming a side. Now friend, what is the meaning of thiopine? You know, the theoretical studies at high level of the theory dealing with the stability of thiopine in the valence tautomers have shown a significant preferred for the valence tautomers benzene sulfide, which was more stable than the parent thiopine. You can see the structure of thiopine here. You can see the formation synthesis, how you will synthesize the thermal rearrangement of cis-1 to divinyl thiopine lead to the formation of the corresponding 4,5 dihydrothiopine. This is the reaction. And another, this is the reactions. You see the cycloaddition reactions by thiopine, thermal reactions by the formation of benzene by the thiopine. Friends, I hope this video will be helpful to you. If you like this type of video, then subscribe my channel, and thanks for watching.